Is it like recording audio also?
Yeah.
Okay. Um, okay, sweet. So, before we get into the content of the slides, there's going to be a coding demo later. So if you don't have Docker desktop installed, please install it. That's how you can follow along. If you just want to watch, like, I guess that's fine too. But if you want to like participate in the demo, then you have to install Docker. You should just go to this link and there will be like a link to install Docker desktop. So you can just do that and have it installing while we go over the slides. So on the agenda today, we're talking about Redis. So we're going to be talking about what is an in-memory database, what Redis specifically is, some use cases, then there's going to be a coding demo led by Avi, and then I'm going to end with like some real-world examples of actual code and like a company that uses Redis um, in their tech stack. So what is an in-memory database? If you're surprised by this, I don't know what to tell you, but an in-memory database is a database that is stored in the system's memory. So unlike regular databases, which use the disk for like storage, reads, writes, and other operations, an in-memory database lives inside the memory or the RAM, which gives it some unique advantages and disadvantages. So some good things about an in-memory database is low latency. So accessing memory is a lot faster than performing any sort of disk operation. So yeah, accessing RAM is much faster than performing a disk read or write. And then a higher throughput, which is like more queries per unit time. So if I had to give an example, it's like if a regular if using a regular database is, like driving a car from point A to point B, then using an in-memory database is like taking a bullet train. And then for higher throughput, if using a regular database is like a one-lane road, then an in-memory database is like a highway with a bunch of lanes. Um, but it's not all good. Some potential disadvantages of this is that the data may not necessarily be persisted, meaning if for whatever reason your system or your in-memory database shuts down or I don't know, you like lose power, whatever, then there's a chance that the data, since it's not persisted, you might lose some valuable information from your like latest operations, which isn't a problem with, it's less of a problem with traditional databases. So some use cases for in-memory DBs is real-time data. Obviously, you're accessing stuff really, really fast, and then fast access to frequently accessed information, which is known as caching your data. So there's in-memory databases, and then there's an in-memory cache. They sound really similar. So what's the difference? So I just wrote some differences here. Starting with performance, in-memory caches are typically more performant than databases because caches aren't worrying about persisting data. So it doesn't have to waste time. There's less overhead with like file IO and that sort of thing. Um, Another difference, uh, obviously, is persistence. Uh, Databases offer persistence at the cost of performance. So I don't know, depending on what your goals are with like your application, you have to pick which of these is right for you. And then the last difference here is completeness. So in-memory databases will store your entire data set. So if you're working with like relatively small amounts of data, then an in-memory database can be a good choice. Whereas caches, they will store a subset, typically like frequently accessed data. So it's a difference of all your data in your memory versus just like what's frequently being accessed by the client. Key takeaway though is that both of these are going to be faster than a regular database. So if you care about speed, then this is good. So that's kind of a brief intro into what is in-memory database and a cache. So now I want to talk about what Redis is. So Redis specifically Um, it's an open source technology, which is really cool. I mean, you can go and read the source code. It's pretty cool. Um, and it's an in-memory database that typically serves as a cache. So it's kind of confusing, but it's a database that serves as a cache, used in front of whatever database or API you might be using. So this is a diagram of how it's traditionally used. So the first step is like client makes a request or whatever. And number Yeah. So first it checks in the cache. It checks Redis, tries to get whatever is at the key. And if that data exists in your cache, then great, you just return it really fast. You don't have to make any API calls or anything, and everyone's happy. But if it's not in the cache, if there's a miss, excuse me, then it'll look in your persistent data store or make the API call and then get those results and finally prime the cache with data. In other words, just like set it so next time that same request is made, it will exist in the cache. And then finally, it returns it in the user. So like I alluded to earlier, you could use Redis as your main database if you wanted to. Redis especially is really flexible and really extensible with that sort of thing. So it's a really popular technology. So some advantages, there's different options with caching out there. I think the other most popular one besides Redis is Memcache. But some advantages of Redis specifically is that it has a lot of support. There's a big community behind it, lots of documentation. I think the Redis documentation is really good and easy to follow, and it's pretty maintained. It's easy to use in your code or your application. And then these last three are kind of the cooler ones. Is the first one is Redis data structures. So traditionally, when working with caches, it works with key value pairs where the key and the value are simple strings. So there's not a whole lot that you could do with just strings. What Redis introduces is these rich data structures that allow you to do more complex operations. And I'll show some examples on the next slide where the key is a string, but then the value is a more useful data structure. Also, I think we'll be sharing these slides. So if it's like underlined, that's just a hyperlink. If you want to like do some more reading on your own. So another cool thing or useful feature is that you can enable or disable persistence depending on what your goals are. So if you want to achieve better performance, better speeds, then you can disable it. Or if you want to be extra safe, you can enable it. And then this last one is also pretty neat. A lot of caches have the system where you can expire keys after a certain amount of time. So what that means is when you prime, going back to here, when you prime your cache with your data, you can set a time to live or an expiration date where after a certain amount of time passes, then that key gets deleted. Because obviously you're working with like memory, you don't want to overload the system. And the way that many caching technologies implement it is you set the expiration time. After that time passes, then the next time the client tries to get that key, so the key's still alive, but next time the client tries to get that key, then nothing is returned and it'll be deleted. But what Redis does is it kind of implements, you could think of it as like garbage collection for expired keys. So there's two types of expiration. There's passive expiration, which is what I just described, where you set the expiration time. After that is over, then the next time the client tries to access that key, nothing happens. It'll just like at that moment, it'll delete the key. But then there's also active expiration. The names are kind of backwards, so it's a little confusing to remember at first, but there's active expiration where in the background, Redis will just probe random keys to see if they're expired or not. And then if they're expired, then it'll delete them. So fun fact, Redis was named the most loved database in Stack Overflow's developer survey in 2017. That's like really old. That's like almost 10 years ago at this point. Um, it's not the most popular anymore, but it's still pretty popular. It's still pretty good. Mhm. So yeah, some examples of Redis data structures um, is this entire list. You can Google these and read more in detail about them. There's string, hashes, lists, sets, sorted sets, stream, bitmap, bitfield, a bunch of these. But I'll zoom in on the example of lists just so you see what I mean. So if you wanted to create a key value where the value is a list, this is using the Redis CLI. I specifically did this example in Redis Insight, which is like a free tool that is really good for visualizing like what's happening with Redis. It's called Redis Insight. It's pretty good. So you do L push to create a list structure with the key Q, and then you can see at each index of the list, there's those tasks that you just pushed. Then if you wanted to pop one of those, you would just call r pop q, right? Pop. And then you can see task one is gone. So just going back, this returns how many elements it added. And this just shows which one was popped. So you can see now task one is gone after performing this operation. And that's something that you can't do that with just strings. You'd have to use like, I don't know, libraries or whatever. It would be difficult. But Redis just lets you do that out of the box. So that's a quick conceptual intro to Redis. Hopefully, if you install Docker, it's done by now and set up. And I was gonna take over for the coding demo part of this.
Does anyone need more time or help with setting up Docker or good? Okay. So this should have been sent in the Discord, this repo over here. It's the repo with all the important stuff. Let me just reload that. Yeah. So if you could go ahead and clone the unfinished branch, this should have everything important except the part that we're about to implement. And then main is just the complete branch. I already have both of them cloned, but you can do this pretty easily. All the instructions are in the README for everything. Like you could clone this, or if you want to go to unfinished and start from scratch, which is what we're gonna do, you can clone this with the branch or the unfinished branch. But I already have both of them cloned here, so I'm just gonna stick with that. The first thing that I'm gonna do is I think this is already done on my machine, but if I head to unfinished, oops. If I head over here and then cd into the CapTeals wiki, uh, the workshop was previously supposed to be demoing a caching a bunch of capitals, but instead we're gonna use the Yahoo like finance stocks, because the capitals, uh, I think it's called REST countries API, is a bit finicky, so I didn't want to run across any errors. Not that Yahoo API has not had its issues in the past, but I just tested it now. Hopefully it doesn't break on us moment of again. So yeah, that's why it's called CapDeals Wiki because I can't spell. So once I'm in this, I'll run npm install. This will, if you run this on yours and you haven't done it yet, it'll probably take a couple of seconds, but I just did it earlier, so it was pretty quick. Nice. So now once I'm in here, there's a couple, well, really only two files that are particularly important. There's server.js, which is empty right now. If you look at the final version, there's all of this, which we're about to type up. Um, and then there's also index.html, which is just like not important for the scope of this workshop, but it's just gonna make things look nice. If you want a quick look at what it's gonna look like, I can drag it into Google Chrome, and then you can see what we're gonna end up making. And that is something that either like a caching system for data for stock prices that either fetches with a cache or without a cache. And you'll see the difference between the time and it's very, very drastic. And also you'll see how caching works where if there's a miss in the cache, what happens, right? Um, so just jumping into it, any issues so far? Nope. Can you move that window there? Perfect. And scroll to the top. Yeah. So I'm just gonna start off. Yep, you can see that by importing everything, and what we're gonna need is Express. Express is sort of something built on top of Node.js, and Node.js is a JavaScript framework for building these um, backend backend services. So the server that we're building right now is going to use Express, and then Redis is obviously very important. Then Axios. Axios is how JavaScript makes get a request from another API. So when we eventually tag the or like ping the Yahoo API, we're going to use Axios for that. And the last thing is cores, which isn't super. I mean, maybe you already know what this is if you've ever made like a front end and a back end have to connect. But there's some protocol in computers that's kind of annoying that two things from a different port number can't connect unless you have this particular thing. And that's just going to be one extra line in our code. So I'm going to more or less skip through the um, like the Node.js stuff because that's not super important for this. But this is the line that we're using cores for. And And yeah, we have a port number. Uh, generally use 3000, so I'm just gonna stick with that. And now is the first piece that's actually using Redis. And what we're gonna use is Ali mentioned a couple of commands like rpop and all of those. But we're just gonna have a basic list here. So the only two important like Redis commands that we're gonna use is flushdb, which is just like a standard emptying of a Redis database. And the second one is going to be setx. Setx is the word set, like you're setting something in a list. Actually, sorry, not a list, a dictionary is what we're going to implement. So set is setting the value of an index in a dictionary, and then x is the word expire. And generally, when you're setting up a Redis database, it's good practice to have it expire at some point so you're not gonna run into any issues later. But speaking of like FlushDB, we have to first initialize and connect this Redis client thing over here. So I'm gonna do that using an async. Yeah. So I have this function over here. It's async, which means that um basically it doesn't run into any issues where say some function takes a lot of time in JavaScript and I believe yeah, Redis client.connect takes like a second or so, maybe even less than a second. But if you don't use an async function in JavaScript, what it does is it skips to the next one before allowing the line to finish. So wait in async, just make sure that everything goes in the proper order. So now I have Redis client is equal to Redis dot create client. So that creates the object, and Redis dot oops on error is just gonna say if there's an error. This line isn't super important, but I was running across a couple errors before, so this just helped me figure out what that was. You can do, yeah. I'll just do a console.log or console.error, that error. So that should be good. And then the await line is await Redis client dot connect. Yep. And then that should be everything with connecting this to begin with. Okay, so now inside this try, I'm gonna do the flush DB thing that I just mentioned. So Redis client dot flush DB. And then you could have like a catch. Oops. This should be air. Um, yeah, so far so good. I'm actually just gonna add like one console.log here to say like flushed. So we can see it once we're actually running the code. So that should be everything with the initial Redis setup. This next part is the actual API call to Yahoo, which I'm actually just going to take from here because it's just using Axios and that's not the topic. So yeah, skipping all of that. This function is just fetching the stock prices from this API. So even if you just type this into like Google, and I'm gonna change the stock to pick a stock, Apple,
Yeah.
Apple, sure. Yeah, so that's a lot of junk, but um I'm sure if you look at price somewhere or like I think it's called close. Yeah, yeah, you can see yeah, the closing prices from the last I don't know how many years, but yeah, you can do that from your own device. You don't need to install anything for that. But all we're doing is taking in that URL and we're using Axios to do a GET request on that, which gives us this response, right? And once you have this response, we're getting the regular market price of uh I think today's market closed like a couple hours ago, so it should be updated with that by now. So yeah, it probably gets today's the current price of a stock. And two extra things that I'm gonna use to sort of act as a benchmark is this date.now and this date.now again, right? So these are sort of getting the time that it takes to do all of this, just so we know that this like how long this process is taking. And there's actually one thing that I accidentally skipped, and that's actually creating the stocks array, um, which I do up here. You can customize this to whatever you want, as long as it's a valid ticker symbol for a stock. Like I could add, I don't know my stock ticker symbols, so yeah, I don't want to mess that up. Um, yeah, but that's initializing this, and then you go through every single stock here, get the price of it using the API, and this is the basis of the no non-caching method. So whatever we do fetch without cache, uh, that's all run by this because this is not using caching at all. So now that I have this function over here, the next step that I need is to actually create the two endpoints. So first one I'm gonna do is slash no cache because that one's easier. Okay. So, yeah. Why does it keep doing that? Okay. All right. So this is sort of in Node.js how you create one of these. Um, this is the final version. Yeah. And this is just using the function that we just made. And there's a try catch. Um, I'll keep the try catch just in case we run across any errors. But that's just like 10 lines of code there. And again, this is async because we're using await fetch stock prices because the point of all of this is to show that there's a lot of time in between things. So we need something asynchronous to make sure that time is all accounted for. Um, and yeah, that's basically it for no cache, nothing too complicated there. And actually, I'm not sure if this is going to break anything because I haven't tested it yet. I haven't tested just running this part of the code. Actually, it will break it. I'm sure of that. So let's not run it just yet. Let's finish everything first. The next part that I'm going to do is the cache. Um, yeah, the cache endpoint. And what that's going to do is basically the same thing as this, except we're going to use the cache that we just initialized up here. So if I don't know why I copied that. Okay, so if I have a try block here, I'm gonna first start off by doing the same thing. where I have start time and end time. Yeah. And then I'm going to actually pull the results from the cache right away. So that's going to be const cache results. There we go. And this cache results is going to return two things. It's going to return like true or false, whether or not um there's actually something in the cache that has what we want. And it's going to return false, obviously, if nothing's there. So I'm just going to have if cache results. And this means that our cache actually caught what we're looking for. If you took comp.org or maybe operating systems, I guess you would have taken comp.org if you were taking operating systems. You know that um like caches have like hit rates and they can miss, and if they miss then there's a process that it goes through. In this case we're just going to simplify that process, and the reason for that is because Redis actually does most of this for us. Like all the like I think you learned LRU cache and like optimizing the cache size to make sure that it's not too big or too small, like the Goldilocks principle. So all of that is handled for us, so all we need to do is if it does hit inside the cache, meaning what we're looking for is in the cache, we're just gonna return that. And that's a lot of typing, so I'm just gonna be lazy for a second and copy that return line. Yeah. So all this returns is the time that it takes, cache n minus start, and the stock prices itself, and also this like quick Boolean value, and that's going to be important for like um whatever it prints out at the top once you run this. And the next part is what if we don't have this in the cache yet? Like what if we're running this for the first time and we actually need to go through the process of fetching the results? In that case, I'm just gonna create a console.log that's like not found in cache. Um, and then I will do the same exact thing as we did for the no cache, pretty much. Yeah, exactly. I think we're good. Okay. So after I pull these results, these are the same. This is the same exact variable as in the no cache endpoint over there. We're gonna use the set x function, and again, that's another really long line, so I'm just gonna copy that over. So set x, we're setting x to the index of stock prices, which is the same get that we use up there. And then we're going to do 3,600, which is the number of seconds. That's the sort of persistency principle that you want to maintain when you're making some of these. You don't want it to last too long before it expires. Otherwise, it's going to fill up really quick and cause other issues. We're only going to be running this like 10 times max, so it's not going to be this huge cache that's going to cause memory issues. But if you are like Google and you're trying to use Redis to create something, um, then you want to have a good expiration time. And then the last thing is we're going to have the stock prices themselves stored inside this. And then that's sending it over to the endpoint. Um, yeah, that should be everything, I believe. Huh? Oh yeah. I do need a catch block. That's important. And one last thing is that I should have put this up here. That's my bad. Um, this should only go if you do actually find it. Yeah. So that's this entire endpoint up here. Um, and the last step we need is app.listen, which is standard for every app that's your server-side application that you're making with Node. And then we're going to listen at the port, and we're going to have a callback function that just says like console.log, like that. Um, and yeah, I believe that's everything here. I'm sure if I run this now, there's going to be like an error or something. But let's try. Yep. What did I do? Oh, Redis client dot on. My bad. Yeah. Okay. Um. Oh, sorry. Yeah, I did actually miss the Docker step. That's very important. If you don't already have the like Docker with Redis set up, I do have the command and the README over here. Where is it? Not this. It's in the unfinished thing, like this over here. If you run this, it'll make this thing show up, but you actually need to click start before it works, of course. So yeah, now if I run this, this should hopefully be fine. And I'm running this without a cache right now. You can see that's around a second at 1.2 seconds. And I can do this again, fetching data using no cache. Now it's even more. It's just a random amount of time. Now if you run with cache, the first time is going to take a while, maybe even longer. Um, because what's happening is in this loop over here, um, oh, maybe I skipped a try catch that actually mattered. Okay. Which one? Like here. Where? Um, Give me a sec. I'm gonna compare with the finish result. Yeah. Result up where? Oh, do I need to name this cache result? Is that the issue? Yeah. Oh, there we go. That's some. Oh, that's why it's saying result not defined. Okay, let's try that again. Oh, I need to run this again. Yeah. All right. So run this. It's the same amount of time as before. Run this. Cache end is not defined. Oh, I called this the wrong name. Oh, it's gonna get me a negative value. Okay, there we go. Yeah, so now if we run this, it's gonna take 779. When I ran it before, it took like 1300 the first time. It's just random luck. But if I run this again, it's gonna run in 2 seconds, and that's because it's actually in the cache now. So um I believe there is a way to view the inside of this view files. Yeah, I think it's in here, but you'd have to dig through this and find the exact like cache that's mounted somewhere in here. Actually, yeah, I don't want to go look for that now, so if you want to try that on your own, go ahead and do that. But I guess that's everything that I really wanted to demo. Um I believe that's it for yeah, that. Any questions on the demonstration or just there's one more part in the slides, right?
Yeah, it's just
Okay.
more code.
All right. Yeah, so Ollie has some more coding demonstrations. Not actually typing something out, but just like examples of how different companies and organizations use Redis. So yeah, I'll let him take it from here.
Um, yeah, so just more coding stuff. I just have a couple examples of different code implemented differently. So there's only two. So the first one comes from Oyster. If you don't know what Oyster is, it's just if you've heard of ColorStack at UF, there's a ColorStack National, and they house all their like core software in a mono repo. It's on GitHub, and you can read through the code. So I was just looking at it, and I saw that they use Redis. Uh, so this just comes from there. Let me move. Okay, what? Well, okay, sweet. So the way this code works is this cache object is just kind of a wrapper around some Redis functionality. It's a wrapper around get and set. So this first function, and this is used elsewhere. So the first function, it gets the value stored in Redis and parses it as JSON. If the key doesn't exist, it'll return null. So obviously, and this is TypeScript, by the way. So it's async, like I was saying, get, and then the key is a string. So it just checks if the value exists inside the cache that, or sorry, if the value doesn't exist, then it'll return null. Otherwise, if it does, it'll parse it as the value, or it'll parse it as T. That's like the type. If you've taken like prog2, you just think of this as like a template function. So it'll return it as that type value. And then down here is a wrapper around the set functionality to set a key. So it'll stringify the value and store it in Redis. Then if an expiration time is provided, because you can choose whether or not to expire keys, then it'll expire after that time. Otherwise, it won't. So again, the key is just a string. The data is of type T, and it'll expire after a certain amount of time. So here it's just making the value. Just waiting for that to and then if there's I'll just point physically. If expiration was passed in or if the expires was passed in, then it'll set it with an expiration value. Otherwise, it'll just set it with no expiration. Quick thing I wanted to point out, in case you're wondering, like what happens if you just keep on setting values with no expiration, like at some point will it be overloaded? The answer is no. Redis has like this eviction policy that once you hit your like memory limit, depending on how you configure the eviction policy, it'll start deleting keys. So for example, you could delete like less frequently accessed ones, less or ones with that have less lifetime left. But yeah, just in case you're wondering. So then this code is then used inside this function here, which it returns the cache or yeah, don't worry too much about this. The point is you're able to make a call to check if it exists at the key. And if it doesn't, then the function will execute some sort of function that you can pass in. So imagine the diagram where first it'll check if there's a hit, if there's a miss in the cache, then it'll like execute some function like API call, check database, whatever. And then so if there's a hit, it'll return the data. Otherwise, it'll await whatever function is passed in as an argument. And if there's no result, then it'll just return nothing, like it doesn't matter. Otherwise, it'll set that value with the key that you passed in and the expiration date or no expiration date, like you just saw before. It doesn't really matter. You can do either one. And then finally, it'll return that result. So an example of where this is called in Oyster is this function. This is somewhere else in the code. This function is imported, and this is like where it's actually used. So const companies await with cache base this is the type, this is the key. Then 1 week in seconds is just a constant that's also defined somewhere else in the repository. And then this entire function, it's cut off, but it doesn't really matter what the whole function is. The point is, this entire function is what's called if there's a miss. And then if there's a miss, whatever the result of this is, gets set to this key. So yeah, this, if I'll actually show the repo real quick. So if you're interested in where all this like Redis stuff is, I think it's just in this Oyster packages, core, source, infrastructure, then Redis. So yeah, you can see this is the whole thing. You know, they're creating their Redis instance here, a bunch of stuff like boilerplate, whatever. Then this is the 1 minute and seconds that you saw. And then this is the actual code. I just took a screenshot. um, but yeah, that's linked if you want to check it out on your own later. And then the last example, I'm not gonna really go into depth in this one. It's just more I put it there because I thought it was interesting, but the complexity of it, it's out of the scope of this workshop. But I encourage you to read it. It's a good read. Comes from a blog post, an AWS blog post, guest written by Tinder engineers, where they pretty much talk about how they use Redis. This is just a screenshot from a diagram that they added. So again, I encourage you to like take a look at this. The idea is pretty much they're just saying like, yeah, we use Redis. This is how we use it. Um, and and yeah, that's it. So any questions or anything about it? I hope you learned something about Redis and you can implement it in your future projects. If you didn't sign in, I don't know if anyone new showed up, but again, if you didn't sign in, just like scan the QR code, um, so you can get attendance. Actually, I think I should probably scan it too. And we'll send these slides later so you can click on all the links and just look at it yourselves.